The following is an AZPM original production.
Arizona Science is supported by Research Corporation for Science Advancement.
For Arizona Public Media, I'm Tim Swindle, Professor Emeritus of Planetary Science at the University of Arizona, and this is Arizona Science. Joining me today is Steve Kortenkamp, an Associate Professor of Practice in the university's Lunar and Planetary Laboratory. Welcome, Steve.
Hi, Tim.
Steve, one of the things you've been doing for several years that fascinates me is making three-dimensional models using 3D printing of planetary surfaces. How did you get started on that?
Well, the short answer is I got started by talking with a colleague in the College of Education who is blind, and he wanted to develop some techniques for teaching students science, students who were visually impaired, who couldn't see. And so he reached out to us and suggested that we use 3D printers to make some of these resources. That was maybe 9 years ago, so it just slowly started building up from there, using spacecraft data and 3D printers to make models of what you and I can see of these surfaces.
What were the first kinds of objects or things that you made models of?
Meteor crater was the very first one. And so it wasn't spacecraft data, it was actually aircraft data flying over meteor crater with a laser to measure the topography. And it was nice because it was local. So most of our students started, they're Arizona students, and so we wanted them to be able to feel our regional asteroid impact crater.
To make a 3D printed model of something, you have to have a digital file with all the details in 3 dimensions. You mentioned getting them from spacecraft or aircraft. How hard is it to find that data and get a hold of it in the right form?
Surprisingly easy for NASA data. It's all public domain data, and there are archives for it. The U.S. Geological Survey has an archive of planetary maps of every surface that's been covered in this way and also just visually. For other data, like for Earth, that's surprisingly difficult to find. We have, as far as I know, we have much better topographical resolution of the Moon and Mercury and Mars than we do of Earth as a whole.
What were the students' responses to this?
So these students, I think, have not had these kinds of resources in the past. And when we were able to get their hands on, for instance, like we have models of the Moon, the full surface of the Moon, the near side that everyone on Earth who can see the near side of the Moon, and then also the far side, which none of us can see with our eyes, whether we have vision or not. But to be able to put in their hands models of these two surfaces and have them compare them by touch, I think that, well, first of all, because the Moon is so different on the far side than the near side, even by touch, are like, whoa, that's a big difference. The reaction, I think, was pretty strong from them, and their level of engagement with the material was, I was kind of blown away by it, and I still am to this day.
Do you have any idea of where you want to take this approach next?
So there's 2 directions we're going right now. One is happening as we speak, and that is using these models in University of Arizona classes for all students, not just visually impaired. I can reproduce these very quickly and inexpensively through a molding and casting process. And so I produce 30, 40 sets of every model that I want. And then I go into a class with 100 students, and we break into small groups, and they use these models to explore impact crater structures, to explore canyons on Mars, things like that, just to study them by touch and by sight. And so that's one way we're using them now. The other way is still down the road, and that is to develop a University of Arizona class that is wholly dedicated to tactile learning with these resources. Not restricted to students who are visually impaired, so anybody can enroll, but that's the goal, to give students at UA who are visually impaired, an alternative to these general education science classes that they don't have right now.
Thanks for talking with us today, Steve, and it will be interesting to see, or perhaps better yet, feel what you produce next. Our guest today has been Steve Kortenkamp, who has been using 3D printed models of planetary surfaces both for teaching and research purposes. This is Tim Swindle, and you have been listening to Arizona Science. You can also listen to this and other Arizona Science segments by going to the AZPM website at azpm.org.
Thank you to Research Corporation for Science Advancement for their support of Arizona Science. AZPM podcasts are made possible in part by donations from listeners like you. Learn more at support.azpm.org. Thank you.